Good afternoon, hope you are all fine. So today we'll be solving example 2 under Thevenins theorem. And our question reads, find the current in the 10 ohm resistor in the network shown in figure 3.48. Use Thevenins theorem. So they want us to find the current in between here, the 10 ohm resistor. So we'll call this node A and node B. So for us to find the current in the 10 ohm resistor, we have to find the Thevenins voltage first and the Thevenins resistor. So for us to find the Thevenins voltage in between node A and B, we have to remove the 10 ohm resistor. Once we remove the 10 ohm resistor, our circuit will look like this. So we have the 20 volts here, 5 ohm resistor, a 15 ohm resistor, we have an 8 ohm resistor, 2 ohm resistor, and a 10 volt source here, the voltage source. We have 2 voltage sources. So what we'll do is we'll use a current divider rule. We have to find the current flowing here. So we'll call this loop 1, the current flowing here in this loop, and also the current flowing in this loop. Yeah. So this will be loop 2, this will be loop 1. So the currents that we are going to find, they are the ones that are going to help us find the voltage sources here, and then once we subtract those voltage sources from the two sides, that will be our Thevenins voltage. So the first thing that we'll do using current divider rule, we'll take this loop here into consideration. So we will call this I1 and this I2. So taking I1 into consideration, I1, we have our voltage source here, we'll say V source, over we have resistor 1, and we'll call this resistor 2, we'll add, which will be equal to 20 volts over 5 ohms plus 15 ohms, which is equal to 20 over 20 will be equal to 1 amp. So the current flowing in loop 1 is 1 amp. And then we'll consider loop 2. So we'll consider I2. So I2 will be equal to our voltage source. So let me say this is V1, this is V2. It will be, since we said this is R2, we'll say this is R3 plus R4, which is equal to 10 over 8 plus 2, which is equal to 10 over 10. So 10 divided by 10, that's 1 amp. So we've managed to find our currents in loop 1 and loop 2. So after doing that, what we are going to do, finding the voltage source, finding our Thevenins voltage in between A and B. So VAB is equal to Thevenins voltage. So Thevenins voltage is equal to, we are going to call this here or as C. So we'll say VAC minus VBC. So VAC minus VBC. How do we find VAC? So the way we get to find VAC is we will multiply. We are going to multiply our 1 amp times the current times the resistor here, and then also this side our VBC. We are going to multiply our 1 amp from loop 2 times the 8 ohm resistor here. So I'll just write it alone here as VAC is equal to 1 times 15, which is equal to 15 volts, and then VBC is equal to 1 times 8, which is equal to 8 volts. So Thevenins voltage is equal to, we said VAC minus VBC, which is equal to 15 volts minus 8 volts. Our answer is 7 volts. So this is our Thevenins voltage. So since we are done finding our Thevenins voltage, now we have to find our Thevenins resistance. So for us to find our Thevenins resistance, we have to redraw our circuit by removing the 2 voltage sources. So since we've removed the 2 voltage sources, this is how the circuit will look like, and this is how it will appear. And then if you look at the 5 ohm resistor here and the 15 ohm resistor here, they are connected in parallel. Also in our second loop, we have an 8 ohm resistor and a 2 ohm resistor that are also connected in parallel. After finding them while they are connected in parallel, the next thing that you will do is add them, since they'll be connected now in series. So let's get into it now. So RTH is equal to, so this one and this one are connected in parallel, plus 8 and 2 are also connected in parallel. So RTH will be 5 multiplied by 15 over 5 plus 15 plus 8 multiplied by 2 over 8 plus 2, which will be equal to 5 multiplied by 15, 5 multiplied, so 15 times 5, that's 75, and then we have 5 plus 15, that's 20. You add them, and then we have 8 times 2, that's 16, and then 8 plus 2, that's 10. And then you can add the 2 that were in parallel, since now they are in series. So you just look for a common factor, that's 20 here, 1 multiplied by 75 plus 10 into 22, 16 plus 16 times 2, that's 32, yes, 32. And then 75 plus 32, that's 107 over 20. So 107 divided by 20, that's 5.35 ohms. That's our Thevenins resistance. And then now we can draw our equivalent circuit. So our equivalent circuit, I'll use my free hand. So our equivalent circuit will consist of Thevenins voltage and Thevenin's resistance together with the load resistance. So our Thevenin's voltage is 7 volts, and then our Thevenin's resistance is 5.35 ohms, and our load voltage, that's the voltage across AB, that's 10 ohms. So now we can find our current passing through the 10 ohm resistor. So we have Thevenin's voltage in our formula over R Thevenin's plus the load resistor. So 7 over 5.35 plus 10, which is equal to, if you calculate, we get the calculator here, our answer will be 0.46 amps. Yeah, that's the current passing through the 10 ohm resistor. So just a recap, for us to find our current passing through the 10 ohm resistor, the first step that we're going to do, we have to redraw the circuit by removing the 10 ohm resistor in between node A and node B. And then what we have to do first, for us to find the Thevenin's voltage, we have to find the currents passing through loop A or loop 1 and loop 2. So we labeled this as I1 and this other side as I2. So finding the current for loop 1, we use the current divider rule, where we have our source voltage 20. Here we put 20 volts, plus we add the two currents since they are in series. We add them and then we divide. We have to find our current as 1 amp. We do the same for loop 2. We have 10 volts. We add 8 plus 2. That's 10 over 10. That's 1 amp. The next thing that we got to do was, for us to find our Thevenin's voltage, we have to find VAC here and VBC. For us to find them, we have to multiply our currents from loop 1, that's 1 amp, multiplied by the 15 ohm resistor. We have 15 volts. We did the same for VBC. 1 times 8, we have 8 volts, and then we had to subtract VAC from VBC. We got 7 volts. The next thing that we did was, since we have found our Thevenin's voltage, we have to find our Thevenin's resistor. So Thevenin's resistance was, the first thing that we did was, we looked at, we had to remove the voltage sources and had to redraw our circuit. This was our circuit, or this is our circuit. If you look at 5 ohms and 15 ohms, they are connected in parallel. 6 and 2 ohms are connected in parallel. So once you find these two in parallel, you have to add them since they'll be connected now in series. This is what we did here. This is our calculation. We found our answer to be 5.35 ohms. We had to draw our equivalent circuit, Thevenin's circuit, where we get to our Thevenin's voltage of 7 volts, Thevenin's resistance of 5.35 ohms, and our load resistor of 10 ohms. Given our formula is like this, we put in our Thevenin's voltage 7 over 5 plus 5.35 plus 10 ohms. Once you add the two, you divide them into 7, we have 0.46 amps passing through the 10 ohm resistor. Thank you.